Good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, today we are going to actually move on to looking at the second stage now of a river valley. But before we do that, let's correct the homework that you were supposed to complete. You were given 3 lots of activities to work on. The first one was explanation with diagrams. The second one to explain the formation of interlocking spur. And the third one, you had a couple of definitions, and you were expected to define those different words given. Okay, looking at the first activity from our work yesterday, you were required, with the help of a well-labeled diagram, to explain the formation of a rapid. We have learned that there are 2 ways in which rapids can be formed. You double-check now. You could select from feature number 1, where a rapid develops when a waterfall of types 1 and 2. When I'm referring to types 1 and 2, I'm referring back to the information that we have covered on waterfalls. The first type is the one where the hard rock lies horizontally. The second type is the one where the hard rock dips upstream. And the third type is the one where you have a vertical intrusion of hard rock along the riverbed. We're making reference to the 2 only, that is 1 and 2. And a rapid can develop when a waterfall of type 1 and 2 retreats upstream. To show that with a diagram so that we understand what the definition is referring to, you have diagrams numbered 1, 2, 3, 4, 5, 6, 7, and 8. You don't necessarily have to have 8 diagrams, but here I'm just putting 8 diagrams to help you understand the development from where the waterfall is, the difference in height from where the fall occurs, to stage 8, whereby the difference is very small. Here we have a big vertical drop that gives us a waterfall. There you don't have a big vertical drop, rather just a flow of water from one perhaps layer of hard rock to the next. And the difference in height there will also identify a rapid from a waterfall. So if you had a diagram to go with explanation 1, this is what your diagram should actually look like. So your explanation will go with the diagrams explaining the development of rapids. You check. The second way in which rapids are formed is basically where you have a hard rock dipping downstream. And with that, if you were to construct the diagram, your diagram should at least look like this. You can have only one diagram, and that one diagram should be well labeled to show us how a rapid is actually developed because of the hardness of the rock. You have the soft rocks. The hard rock must actually dip downstream. And at the top here, if the river is flowing, then you have the rapid being formed in this area or region. Okay, you double check and you make your corrections, because those were the first 2 lot of activities that you were expected to make note of. Sorry, not 2, but the first activity you were expected to make note of. Okay, the second activity, you were supposed to explain how interlocking spaces are formed. There was no need for you to construct a diagram. All you had to do was to write a written explanation on the formation of interlocking spaces. You check. Your explanation should have information similar to what I'm going to look at now or go through. Vertical erosion, very important, rapidly deepens the valley. The river that flows along that valley twists and turns around obstacles of hard rock. Erosion is actually pronounced on the concave banks of the bend, and this ultimately causes the spurs, which alternate on each side of the river, to interlock. So your explanation should be similar to that information from the monitor. You double check. That's not all. You note also the undercut concave banks, that is the erosional bank, would usually stand up as river cliffs. Meanwhile, on the opposite side of the bank, that is the convex bank or the depositional bank, there is little or no erosion. On that side, the convex bank, the bank would usually form what we call gentle slip-off slopes. So that is on the explanation on the formation of interlocking space. You check, make corrections. Okay, finally, activity 3. That is to do now with definitions. So we'll check, and we'll get some of you to read out your definitions for activity 3. Christopher, the mic is with you there, so you tell us or give us the definition for rapids. That was the first word that you were expected to define. Rapids?
An area of broken turbulent water in the river channel caused by a stratum of resistant rock that dips downstream.
A bit too fast, so Christopher is going to explain that again, so the rest of us could check and make corrections.
An area of broken turbulent water in the river channel caused by a stratum of resistant rock that dips downstream.
Okay, so he's looked at an area along the river bed of which is actually formed as a result of the dipping of the hard rock, usually downstream. So he has used the first example of the way in which, the second example of which the way in which streams are formed to give his definition. Any other person would like to also read out the definition they have for rapids? Rapids again, Susan, thank you. We're still on rapids?
A rapid is a swift current in a river caused by a steep downward slope in the riverbed.
Okay, very good. We can also have that as a definition. Anyone else to give the definition you've gathered for rapids? No one? Okay, I'm just assuming that most of you have definitions similar to what the two students have given. We'll look at the second definition this time, interlocking space. Elsie, interlocking space, definition.
Interlocking space are obstacles of hard rock around which a river twists and turns in a V-shaped valley. Erosion is pronounced on the concave bends. This forms spurs which alternate on either side of the river and interlock.
Okay, very good. You can have that as a definition. Anyone else? Definition of interlocking space? Catherine?
Interlocking space are a series of ridges of land projecting out on alternate sides of a valley and around which a river winds its course.
Okay, very good. That is also another definition that you can have for interlocking space. Okay, we'll work on the assumption that a lot of you would have one or the other, similar to what the students have given for the definition on interlocking space. We'll move on. Let's look at concave banks. Anyone with a definition to what concave banks are? Anita, your definition or explanation to concave banks?
Concave banks are the bend in the river where the river flows most rapidly and erosion is effective.
Okay, very good. The bend along the river of which erosion is actually dominant. That bend or that side is referred to as a concave bank or bend. Ebony, convex bank.
The bank on one side of a river where deposition takes place.
Okay, good. Here we are looking at the opposite to concave, and if we are saying the opposite to concave, if concave is the erosional bank, then obviously convex would have to be the depositional bank. That is the bend or the side of the river where deposition is dominant. Slip-off slopes. Gibest, your definition.
The relatively gentle slope at the inner edge of Menda and east this is one side of point bar deposit.
Okay, Gibest has given us the definition of what a slip-off slope is. It is generally a relatively gentle slope at the inner side of a meander. So if we are looking at the inner side of the meander and we go back to the two words convex and concave, which of the two words would we expect to find a slip-off slope? At the concave bank or the convex bank? Will have to be the convex, the inner slope or inner side. And that is also, it is also a site where a point bar can actually be formed. And a point bar is a depositional feature of which when we look at features formed towards the end stage of a river, we will be expected to define that also. Okay, that's for slip-off slope. Anyone else would like to give the definition of slip-off slope? Anyone else for slip-off slope? Okay, we'll look at the last one, which is river cliffs definition. Noel, your definition of river cliffs?
Features or cliffs created as a result of fast flowing current.
Features or
Cliffs.
cliffs which are created as a result of the fast flowing current or as a result of erosion. Okay, we'll double check. We should all know what a cliff is. It is a steep rock face. That's what a cliff is. A cliff can be formed anyway. It can be formed as a result of uplifting, folding, and faulting. It can be formed along the coastlines. It can also be formed along river bed. Sorry, not river bed, but river banks, the sides of the river. Okay, when we are looking at concave and convex bank, we already said that slip-off slopes are common along the convex banks. So therefore, river cliffs are common on the concave banks because that is where erosion is dominant. And these are the steep rock face along rivers of which are formed as a result of river erosion. Okay, to check and make corrections to slip-off slopes and river cliffs, I'll give you at least a minute to double check on the definition which is there on the monitor. You make your corrections and then we will move on to looking at what I'd like us to look at for our lesson today. 1 minute to double check and make your corrections. Okay, done your corrections? Okay, now let's move on. And as I've mentioned in the beginning that I'd like us to look at the second stage of the river now. We have moved away from the first stage of the river, which is the youthful stage or the torrent stage of a river. And now we are moving to the second stage of the river. And in the second stage, some of the terms that we can use to describing this stage is the mature stage or the valley stage. That's the second stage of the river. Okay, we come back to this chart that we have looked at when we started off with our work on river studies. And for the second stage, this is the section that we are going to actually be making reference to. The mature stage, the valley stage, or the second stage of the river. And it's from this end here to that end. Okay, some of the characteristics that you should keep in mind on the second stage of a river valley now are, number one, when you make comparison to the flow of the water in the river channel or the stream channel with the first stage, how do you think we can describe the flow of the water? Is it going to be fast as in comparison to the first stage? No, it's going to be a little bit slower. So if we're going to use the word fast flow in the first stage, perhaps in the second stage we can use medium flow. So the flow of the water itself along the channel is now medium by the time it comes to the second stage. Look at the bank of the river. In the first stage, the bank is narrow. In the second stage, the bank will now be widened. It will not be very wide, or it will not be narrow. It will be just widened in comparison to the first stage. Okay, so the bank becomes widened. We also looked at vertical erosion is dominant in the first stage. This time when we come to the second stage, lateral erosion now will become dominant. And because of the lateral erosion in the second stage, the shape of the valley will no longer be V. Rather, the valley in the second stage becomes a U-shaped valley. So if we go now to our diagram and perhaps a quick illustration of that information on the board. In the first stage, we had the V-shaped valley, and the V-shaped valley was as a result of vertical erosion. In the second stage, that V now will tend to a U-shaped, and the U-shaped is as a result now of lateral erosion. By the time the river flows to the second stage, the water is flowing a little bit more slower in comparison to the first. Therefore, that effective power of eroding head-on is actually no longer there. As a result, the water slows down and it starts to twist and turn, or it starts to meander. And because of the meandering, it means that the bank or the sides of the river, deposition will start taking place on the convex side, and erosion will continue on the concave side. This is where we now start to see the interlocking space, like what we have looked at in the first stage, starts to actually widen. And when it widens, we start seeing the development of what we call a floodplain. And the development of the floodplain later in stage 3 will be well developed, and by the time it is well developed, those depositional features become dominant and common. But we are looking at stage 2, and in stage 2, U-shaped valleys are created, and the U-shaped valleys are created as a result of lateral erosion. In this particular stage, erosion becomes dominant on the concave bank. Meanwhile, on the convex bank, deposition starts to form. In deposition, slip-up slopes are actually formed. In erosion, river cliffs are actually formed. You look at the bank of the river, and instead of the river flowing in a straight bank, the river then starts to slow down. Therefore, it starts to twist and turn or meanders. The meandering then will also contribute to the beginning of the development of a floodplain. Okay, from the diagram on the monitor, the U-shaped valleys which are formed as a result of lateral erosion. Here you have the U, no longer that V where the cutting is straight down. You have an open V as a result of lateral erosion. If we had to look at an example of a feature that we've learned about in the first stage, the interlocking space, note there the diagram A, B, and C, A, B, C, they show us examples of interlocking space. Pay attention to this diagram here. We have A, B, C to show us the interlocking spur. Note in particular the shaded area next to where the river is flowing. This area here with the broken line, and it's shaded in black. Note that area. As we go to the next stage and the continuous erosion and deposition on the concave banks, the convex bank. You can see now that as the river meanders down, it starts to actually cut the interlocking space, and it starts to open them out. And the opening or the cutting then will result then in a flood plain developing or a flat floor which starts to build up. That flat floor you can see is referred to now as the U-shaped valley. Here you can see erosion again and deposition being dominant. Erosion on the outside band, the concave bank, deposition mainly on the inside bank or the convex bank. And here, the deposition then starts to build up with alluvium or alluvial. The alluvium or the alluvial deposits can also build up features such as deltas or levees later on that we are going to study on, especially on the last part. This is from the interlocking space, the widening now to giving us this feature here, the U-shaped valley. We continue. You remember that diagram that I was asking you to make reference to, especially on the shaded area. Here, you will note now that the area gets to be widened. There is more now to the widening of the shaded area. The X representing the depositional bank and the Y representing the erosional band. Note the flow of the river. The flow of the river is cutting hard at this side. Erosion is dominant here, meanwhile inside, deposition. The flow of the river, erosion is dominant here, meanwhile on the inside, deposition, and that continues down following the flow of the river. This is similar to the explanation of what is on the chart. If we had to look at a cross-sectional view of that particular diagram, that is making reference to this, if I had to look at a cross-sectional view to show the slip-off slope and the river cliff, we can have a cross-section drawn up as shown by this diagram here. And you note this is the area of deposition, so this is where you have the slip-off slope. Meanwhile, this side here, the Y side will show us the undercutting, and that is where the river cliff is. Note the arrow. The arrow here shows the flow of the water is actually undercutting here, resulting in erosion. Meanwhile, this red arrow here shows whatever material that is actually being eroded gets to be carried and deposited on the opposite side or the convex bank. So this is a cross-sectional view showing us the same information as that. We move on. In time, the continuous erosion and deposition will now see the widening of the river flow. You will see now it is widened as in comparison to the first two diagrams. And here we now have seen the development or the building up of a feature which is known as the floodplain. The floodplain is this whole area here. Look at the diagram again on the side. You can now see the floodplain well established or well developed. Meanwhile, the river continues to flow. And then as it reaches the last stage or the final stage, the floodplain then becomes well developed and a lot of depositional features are actually created or formed. Those are some of the samples or examples of what is actually found on the last stage of the river valley or the floodplain. Any questions? Questions? So if I had to ask you, in the second stage of the river valley, what would be some of the characteristics that you should be able to recognize? 1, the U-shaped valleys. 2, lateral erosion is actually dominant. 3, the flow of the water would be a little bit more slower in comparison to the first stage. I did not mention anything about the gradient, but what do you think or how do you think the gradient could be described in the mature stage or the second stage of a river valley? Gentle? No. If you say gentle, that means it will already be in the last stage. It's not going to be gentle. If we are saying the gradient in the first stage is steep, the last stage is going to be gentle. How about the middle stage? Moderate. Good. The gradient in the second stage is supposed to be moderate. Note also in the second stage, another important feature that we must be able to pick up is the erosional bank and the depositional bank. That is important. We should be able to pick up also. The meandering or the winding of the river also, the start of the meanders is also another important feature in the second stage. So you see, those are all the things that we have looked at in the second stage of the river valley. If we have no questions, the next or the activity now that I would like to assign. Remember, I mentioned something about giving an activity of which you will be working in groups. And then you are going to compile or put your information together, and you will also present the information that you would have compiled and put together. You are going to work in groups of threes, 3 people in a group. To the pilot teachers, you might want to put 4 or 5 students in a group depending on the number of students in your class. I have 34 or 33 students, so we are going to put you, or I will put you into groups of threes, so you will work in threes. Okay, in your groups, this is what you are going to do. You will see that there are 10 words of which we have not looked at the explanation to how those features are formed. So in your groups, you will select only one of the feature. You are going to select in such a way that not 2 groups are doing the same feature. Every group will have to do a feature or a different feature. I have 10 words here. For the pilot teachers, there are other words that you would like to include, you may do so. If there are other words in association with what we are covering on river studies that you'd like to include so that the students can work on it, you can include. So here goes for the class, we have 10 words. Plunge pools, peneplains, river braiding, levees, deltas, gorge, canyon, floodplains, oxbow lakes, and meanders. Whichever word you get to actually work on in your group, you will be required to explain or to define that particular feature. That's number 1. Number 2, you are going to actually present the feature that you will be given to work with, and your presentation should include putting that feature on a chart so that the other students are able to also know how that particular feature is actually formed. So you select a feature. In your groups, you put that feature on a chart, and that chart should show the formation of that particular feature, and your presentation will be to explain to the rest of the class how that feature is formed and the different stages in the development of that feature. Just in case you're wondering how you are going to do that presentation, we go back to stage 1. Remember potholes, interlocking space, waterfalls, and rapids? I was able to give you an explanation of those features, and I also showed you how those features are formed. You are going to do the same for these features here, but your work is going to be done in groups. Okay, having given you that task, we are now going to organize ourselves so that you are put into your groups, and then you will have to select one of those features. Are we happy with where we are sitting for our groups? Yes? Okay. Those groups then, perhaps when you go back to the classroom, what you are going to actually do is, those words will be written on a piece of paper, and a group member simply goes and picks up one of the words from the box, and then whichever word you pick up, that's what you and your group will work on. Okay, and that's what we are going to do for which word you are going to actually pick for your group. Any questions on the activity that you are going to do? Yes, Val? The presentation? The presentation will be, perhaps I'll give you the next lesson, time to work on it, and the following lesson we'll start off with a presentation. Okay, not the next lesson. The next lesson I'm going to go ahead to the other, say, explanations I'd like to do, and that means you are given one day for the completion of that work, and then the following lesson you will be presenting the information. Any other questions on the activity or on the group presentation or group work? Yes? Are we clear on what we are expected to do? Okay. That will also bring us to the end of the lesson. Class, if you can stand up now, please. To the pilot teachers, our keyword for lesson 75 is convex banks. Good afternoon and thank you, students.